Okay, so now I'm going to talk about how to operate the Sorval centrifuge. This is a Sorval RC6. The centrifuge is capable of really high speeds. This is the centrifuge that can create the highest number of G-force, for any sample. For this centrifuge, we would spin this. If you need to spin very large samples because it has our largest rotor, or very small samples at very high speeds. This is really good for pelleting really small things like cell organelles or broken pieces of cells. They're very small and they require high G-forces to pellet them to the bottom of the tube. Since I just lysed cells, I have cell suspension here. I have two tubes which I have scrupulously balanced. They are balanced to within a 1/100th. I'm spinning these at very high speeds, so I want to be 100% confident that the tubes are equivalent. These are also very special tubes. I didn't just use any tube. These are specific tubes designed to fit in this rotor and can withstand the G-forces of this centrifuge. If you are not clear as to what kind of tube to use, please consult with the instructor. But these are a polypropylene copolymer. They can withstand G-forces upwards of 40,000. So these are not going to break inside the centrifuge. If you are not sure if your tubes are rated to high G-forces, again, please check. Do not just use them. They could break inside the centrifuge and kill us all. So, again, I have my perfectly matched tubes. These are little. We have two rotors in ours that fit this centrifuge. We have a large rotor. This is very big. It's called the SLA 1500. It's currently upside down. The other rotor we have is this little guy called the SS34. Inside this rotor, you see I have some white and some dark holes. These are adapters that fit inside this rotor. The rotor should be clean when you get to it. This one's mostly clean. These adapters are here to fit specifically these tubes. So you should not be running this tube in this rotor without a white adapter. Again, if you are unsure as to whether or not your tube requires an adapter, please check before running the centrifuge. You want to dry off your tube before placing it in the rotor, and you want to place your perfectly balanced tubes directly across from one another. So I have them in my rotor. The other thing I want to show you is how to actually seat the rotor on the spindle. So we have a hole here, and this rotor is going to sit on top of a spindle. And actually, I'm going to pull these out so I can flip this over and show you something. Okay, so inside the spindle shaft of this rotor, you can see at the top we have the head of the rotor. And there's a cap there, and inside that cap are two pegs. They are metal pegs, and they are designed to help keep the rotor from spinning when it is on the spindle inside the centrifuge. Those two pegs cause all of the problems that we have with maintaining the centrifuge. If the rotor is improperly seated on the spindle shaft, those two pegs can be broken, they can be ground down by the sheer force of the centrifuge. The rotor could slip off the spindle and could actually pop off of the spindle shaft and cause tremendous damage to the centrifuge. So these pegs on the inside of the rotor shaft, or on the inside of the rotor cap, are incredibly important to know about. So we have the two pegs. How do you know where they are? In this rotor, it's a little bit challenging, but they line up with one of these two sets of screws. How do you know which one? Well, to be safe, you should assume both. So it's going to line up with one of these two sets of screws. We need to make sure that these two sets of screws are lined up to fit in between the pins on the spindle shaft. We're now looking at the centrifuge. I've got my rotor, and I'm looking at those four screws. Inside the centrifuge, we have a spindle. Where is it? There you can see it. It's black, and on top of it are four pegs. You want to make sure that those four pegs are, for example, at 1 o'clock, 4 o'clock, 7 o'clock, and 11 o'clock. And the four pins on my rotor are at 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock. This makes sure that my rotor pins are aligned with my spindle pins and avoids this problem where the two pins land right on top of each other. That is a fatal flaw, and that will cause major problems. I'm making a big deal about this because this is, out of the last 5 major centrifuge repairs, this has been the cause of 4 of them. So we seat the rotor on the spindle, taking care that those pins are lined up. We put it in and we give it a little wiggle to make sure that it is seated correctly. Next, we're going to put in our tubes, making sure they're dried off, and we're putting them in opposite each other. If the rotor has multiple adapters in it, there's no reason to spin them with extra adapters. So the extra adapters can go here on the bench top or in the drawer. Just the 2 tubes. We then have a lid. Every lid matches the centrifuge. This is the SS34 lid, though it looks kind of backwards now in my video. I'm going to be screwing this on. Notice that the off goes in a right-hand or clockwise direction. This is backwards of what you would normally think. You'd normally think lefty-loosey, righty-tighty. Clockwise would be tightening, but this is backwards because the rotor instrument's going to spin in a counterclockwise direction. So they want you to, they have it loosened in the opposite direction. So we put this on the centrifuge, tightening the large wheel first and then the small wheel second. It's again extremely important to tighten these finger tight. These do not have to be He-Man tight, just finger tight. And show you what it looks like inside the centrifuge. So there's the rotor with its lid inside the centrifuge, and I'm tightening first the large and then the small. Maybe next time I should have someone help me do the video, huh? So these have to be finger tight. I'm going to actually turn on the centrifuge now. So once I have tightened these by my finger, I want to run my fingernails around the lid. And I'm doing that to make sure that there's no space between the lid and the actual rotor. If you feel space, if you can fit your finger in, then you have not seated the rotor and or the lid correctly. You should undo it and try again. You should also tug up. Put your fingers underneath the rotor, grasping it in 2 hands, and gently pull up. If you feel any give, if the rotor moves at all, you should undo the lid and reseat the rotor. So I have passed both tests. My rotor, I can't fit my fingers under the lid, and when I tug on it, I feel absolutely no movement. So I've turned the centrifuge on, and now we can see the actual run screen. It's telling me the door is open, which makes some sense. So I'm going to go ahead and close the door. It's making a terrible noise. Okay. So there's a couple of things we're going to consider in this area, which I think is actually looking backwards on my video, but oh well. This is the speed, the time, the temperature, acceleration, and deceleration. You can also look at, right here is the RCF, which is the G-force. So if you have a protocol that requires G-forces versus RPMs, you can switch between using that button. So right now I'm trying to pellet cell debris. That means I have a suspension that is broken cells and proteins. I'm trying to separate the broken cells from the proteins. I need to spin at relatively high G-forces in order to accomplish that. So the first thing I'm going to do is actually select my rotor. My rotor was the SS34. It's rotor number 5, so I hit 5 and enter. It's telling me right here that the SS34 has a maximum speed of 20,000 RPMs. What you heard just then was the condenser of the centrifuge turning on. The centrifuge has a refrigeration unit, and occasionally the condenser turns on, especially when the door is closed. So right now the centrifuge is at 21 degrees. I have it set for 4 degrees. So it's going to turn on and cool the centrifuge down. That is by far the loudest part of the centrifuge. This is the condenser turning on. So don't be alarmed, but you learn to recognize the noise. So this can go to 20,000 RPM. There's no reason to run this at maximum speed. That's just asking for trouble. So 15,000 RPM will be totally fine. Using the arrows, you can see that now I'm in this area. So I can hit 15,000 and enter. I can then go over here, and 40 minutes is a good time for spinning cells down, anywhere from 30 to 40 minutes. I like my cell suspensions particularly clean, so I'm going to do 40 minutes. Acceleration and deceleration, the maximum is 9. Again, there is no reason to spin at maximum acceleration and deceleration. That's additional. You're operating the centrifuge at its maximum capacity all of the time, so we have it set for 8. Please do not change that. If you come down, if you continue to arrow through, you'll notice that the numbers briefly go to 0 and then return to their set values. So if I was looking to choose G forces instead, I would choose RCF, and then I could select a certain number of Gs. Gs differ between centrifuges. The amount of G-force is dependent on the radius of the rotor, and so therefore it is not, you cannot translate RPMs between centrifuges. 15,000 RPMs on one centrifuge is not the same as 15,000 RPMs on another centrifuge. The only thing you can translate is G-force. And so if you are following a protocol from a paper and they say they spun at 20,000 Gs, that's different than 20,000 RPMs, and it's dependent on the radius of the rotor. You can see that it's now recognized I have 15,000 RPMs, which is equivalent to just under 27,000 Gs. Again, that's sufficient force to separate proteins from broken cells and mitochondria and things like this. So that will be fine. Once I've got all of my things set, I want to ensure that the door is closed. It's very important that you do not lean on the centrifuge. I have a message here. Where is it? Oh yeah, it's definitely backwards. Do not lean on the centrifuge. And why is that important? Well, if you lean on the centrifuge, this has special feet in order to balance it. If you lean on it, you can push the centrifuge off balance. Again, this is spinning at incredibly high speeds. Think about a washing machine. If you load a washing machine and you load it in balance, so you put a bunch of towels and you just throw them in, you don't take the time to smooth them around and get it nice and level. The washing machine, when it goes through the spin cycle, will actually like rock and buck, and it'll be really, really unstable. Now, a washing machine isn't going even a fraction of the speed as this thing can go. So you can imagine if you have an imbalance inside, either inside because you didn't balance your tubes correctly, or outside because you pushed on the centrifuge and it's now not level, this thing could just rock itself right through a brick wall. And that can be very dangerous. So you don't want to lean or put your body weight on the centrifuge. Next, the lid is of a particular concern. The lid has a handle right here on gripping, and you actually have to squeeze to open the door. You push it down gently. Every time you open the door, it asks you again if you've changed the rotor. I have not changed my rotor, so I'm just going to press enter. I can keep my rotor, that's on the seat. There is no need to slam the door, or again, put your body weight on the door, not necessary. Just close the door carefully. Now, in the past, this door has been severely damaged. That can cause some problems with the actual safety mechanisms of the centrifuge. Not that the centrifuge is unsafe, but that its ability to sense whether or not the door is closed has been compromised because of damage in the past. So one of the things that can be helpful is this little handle right here that you have to squeeze has to actually contact a certain sensor on the inside so the centrifuge knows the door is closed. You can help the centrifuge know the door is closed by actually, see, I've turned my hand over and now I'm pushing on that little handle. I'm pushing it down to make sure that that little sensor on the inside is making contact. And so that will help the centrifuge know that the door is closed. I hold this down until my centrifuge has actually acknowledged the door is closed and has started to spin the rotor. Again, the door is closed, it is safe, but that little sensor has received damage in the past. So watch out for that. So now I'm set for 15,000 RPMs for 40 minutes. I'm accelerating and decelerating at a level of 8. This happens to be about 27,000 G forces. And I'm ready to go ahead and start. So right now I have a little picture of the rotor in the corner. There was the condenser again, right? A little picture of the rotor in the corner and it says stop. As I hit start, it's going to say accelerate. And notice I'm holding this little piece of the door down. It's going to accelerate very slowly. It's going to take the opportunity to check a couple of things. It's going to check the identity of the rotor. It can do that because on the bottom of the rotor are placed a couple of magnets, and the computer on the centrifuge knows, based on how far the magnets apart are and how fast they're going, what centrifuge rotor you have. And it's going to check to make sure you haven't made a mistake. You hear a small whirring sound as the centrifuge speeds up. It's going to pause briefly at around 3,000 RPM, around there. It pauses briefly to check the balance. If the balance is out of whack at that moment, the centrifuge will hopefully catch it and stop. If it doesn't stop, I stand here with my finger on the stop button, because if at any moment you hear any asymmetry in the way the centrifuge is operating, you hear any clunking, you hear anything that sounds like thump, 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 you immediately hit the stop button and then you remove your body physically from the area. We have no idea what could happen. The rotor could break through the side of the instrument and it could be exceedingly dangerous. So you need to step away. If you hear any kind of asymmetric movement, hit the stop button and walk away until it has stopped. Now right now I have spun all the way up to 15,000 RPMs and my centrifuge is basically silent. You hear almost nothing. That is normal. You hear a little whirring sound, a little high-pitched whirring noise, and that is normal and okay. The condenser might turn on, in which case the sound is coming from the back of the instrument. It's that sound that when the condenser turns on to try to cool the instrument down. Again, that is okay. That is not a sign of an imbalance. Generally, an imbalance or broken tube or something during a run that causes a problem will sound like a banging or a knocking noise. And that's me knocking on the table. That's not the centrifuge. So if you hear any kind of thumping or knocking that is in any way asymmetric, you just hit the stop button and you walk away. Now, when this is done, there was the condenser. Again, that wasn't an imbalance. That was just the condenser turning on. When this is done, the centrifuge will not let you open the door until it has come to a full and complete stop. It will actually sing a little song when it does that, comes to a full stop, and you can then open the door and get your samples out. You should check first to make sure there have been no leaks. There have been no leaks from the tubes. Any leaks in the tubes require that you wash the rotor with soap and water, and that you immediately throw away those tubes. If a tube leaks, you throw it away. We do not want to worry about whether or not it is cracked. A cracked tube can actually fail inside the centrifuge and break, and that can cause big problems. If you see a tube has leaked, you throw it away immediately. And you notify the instructor so a replacement can be purchased. So once the run is done, you're going to take your tubes out, ensure they have not leaked, and then you take the rotor out of the instrument. You place it here on the bench top. There are 2 spots indicated for the rotors. You place it here on the bench top next to the centrifuge. You leave the door open on the centrifuge and you shut off the power button, which is located here on the front of the instrument. You shut off the power button. This video does not constitute actual first-time centrifuge training. If you have never been trained before and you need to use the centrifuge, you must be trained by myself in person. But if you previously have received training and you are simply renewing your training for another school year, you may watch this video, answer a couple of questions, and then you can have centrifuge training access for the semester. Okay, thank you very much.